Hi all. Today we are going to discuss about HPLC. HPLC means high performance liquid chromatography. High performance liquid chromatography is a powerful tool in analysis. First we will discuss about chromatography. Chromatography is a separation technique in which separation of mixture of samples into individual samples will be takes place between stationary phase and mobile phase. Stationary phase means the substance on which absorption of analyte takes place, and mobile phase means solvent which carries the sample. Then next, liquid chromatography. Liquid chromatography is a technique in which mobile phase is used as the liquid. If suppose we are going to use the gas is the mobile phase means it's known as the gas chromatography. The main principle involved in the liquid chromatography is adsorption. The principle of liquid chromatography is, if suppose we are going to inject the sample into the column, there will be some physical and chemical interaction takes place between column material and components present in the sample. Then the sample will travel according to their relative affinity towards the stationary phase. Then the component which is having the more affinity towards the stationary phase travels slower, and the component which is having the less affinity towards the stationary phase travels faster. It means if suppose the compounds having the more affinity to stationary phase means they will stick to the stationary phase and then elute late. If suppose samples having the less affinity towards the stationary phase means they will elute fast. Then next, types of HPLC. Based on mode of separation, based on principle of separation, based on elution technique and scale up operation and type of analysis, there will be 5 types of HPLC are there. First one is based on mode of separation. There are 2 types of modes will be there in the separation. First one is the normal phase HPLC and the next one is the reverse phase HPLC. In normal phase HPLC, polar stationary phase and non-polar mobile phase will be used. Polar stationary phase means mainly silica is used. In normal phase, mobile phase is used as the non-polar mobile phase. Non-polar mobile phase means mainly hexane, methylene chloride, chloroform, diethyl ether, and mixture of these solutions will be used. Then next, reverse phase chromatography. In this, the stationary phase is non-polar and then mobile phase is polar. Non-polar stationary phase means mainly C18, C8 cyano columns will be used. C18 column means the silica is attached with 18 carbon groups, and C8 column means the silica is attached with 8 carbon groups. Cyano columns means the silica is attached with cyano groups. Then mobile phase is polar. Polar mobile phase means water, methanol, acetonitrile will be used. Then next, these are some differences between the reverse phase chromatography and normal phase chromatography. And the next one is based on principle of separation. There will be 2 principles will be there in the HPLC means chromatography, not in HPLC. Mainly in chromatography technique there will be 2 principles are there, mainly adsorption and partition. Adsorption means the separation takes place between a solid and liquid, which is known as the adsorption chromatography. If suppose the separation takes place between the 2 liquids means it is known as the partition chromatography. Dilution. During the chromatographic analysis, a pump can deliver a constant mobile phase throughout the analysis means it's known as the isocritic elution. If suppose in between in the middle of the runtime, if you are going to change the composition of mobile phase or the increasing the mobile phase composition means it's known as the gradient. Mainly the gradient elution technique used for the complex mixtures. It means if suppose one peak analysis means we are going for the mainly isocritic elution. If suppose 2 or more peaks are there, it means 2 or more components there in the one product means mainly we are going for the gradient elution for a good separation. The next, based on scale up operation, there will be scale up operation. 2 types of HPLC are there, analytical HPLC and preparative HPLC. Based on type of analysis, qualitative analysis and quantitative. Qualitative means just the detection will be there. Quantitative means detection and quantification will be there. Now instrumentation. The HPLC involves almost 6 parts. There are solvent reservoir and mixing unit, high pressure pump, sample injector, column, detector, and data recording system. This is the HPLC instrumentation overview. These are the solvents. It means these are the mobile phase. It is the pumping unit. This is a mixer. This is a sample loop, and this is the injector, and this is the column. From here we are going to inject the sample into the sample loop. From this sample loop, the sample will move to the column where the sample and mobile phase will be mixed. There will be some chemical and physical interaction takes place between sample and the column, and then based on affinity the sample will be eluted, and in this detector it will be detected. Now we will see the parts one by one. First one is solvent reservoir and mixing unit and degassing system. Solvent reservoir means then appropriate mobile phase will be filled into the mobile phase bottles, and then they will pump by using the pump to the HPLC system. The mixing unit will mix the mobile phase based on the composition. Then degassing system is the means some several gases also there. It means soluble in the organic solvents. If gases are there means they will interrupt the chromatogram column. It means the solution is pumped with high pressure, so there will be generation of gas bubbles which will interfere with the separation process. So we are going for the degassing system. Degassing mainly done by vacuum filtration, helium purging, and ultrasonication. Mainly ultrasonication will be used. In this there will be sonic waves. By the sonic wave we will going to remove the air bubbles in the mobile phase. Then next, high pressure pump. The role of pump is to force a liquid through the liquid chromatograph at a specific flow rate. Mainly the flow rate is used in the HPLC are 1 to 2 ml per minute, and the pressure of the pump mainly ranges from 6000 to 9000 psi or 400 to 600 bar. There are several types of pumps used in the HPLC, mainly reciprocating piston pump, syringe pump, and constant pressure pump. The next one is injector. The injector serves as it will introduce this liquid sample into the flow stream of mobile phase. Mainly the sample volume is 5 to 20 microliters will be used. The injector must be withstand with high pressure of the liquid system. There are two types of injector will be there: manual injectors and automatic injector. Manual injector means user may manually inject the sample into the into the column. It means there will be some port will be there. This is the port. In this we have to going to inject the sample. If suppose automatic means automatically the system will inject the sample into the sample port. Then next, these are the manual injectors. This is the automatic injector. Next is column. Column is the main part in the HPLC. It is known as the heart of HPLC. It means mainly the separation takes place in the column. Initially only we discussed in principle the sample will be separated based upon the relative affinity towards the column. If suppose more affinity means it will elute late, less affinity means it will elute fast. The columns used in the HPLC are generally made up of stainless steel because if high pressure will be used so to withstand that high pressure we are going to use the stainless steel columns. The columns mainly the 20 to 50 centimeter length, 1 to 4 millimeter diameter will be used. The particle size should be a porous particles 20 to 40 micrometer. For the porous microparticles it should be 3 to 10 micrometer. Softwares used in HPLC: ChromeNow 2.0, Jasco HPLC, Lab Solution, Shimadzu, M-Power3, Hitachi, OpenLab, Agilent, M-Power3, Waters Corporation. Then next, application of chromatography. mainly for purification of the sample, identification of compounds, determination of impurities, separation of mixture of samples, and determination of the concentration of the drug, biopharmaceutical and pharmacokinetic studies, drug stability studies, qualitative and quantitative analysis, and next environmental applications like analyzing the air, water, pollutants. Then next quantitative analysis example, to measure the concentration of the each compound in a sample. Quantitative means we are going to quantify the sample. There are two ways to quantify the sample in a chromatogram. First of all is the height of the peak. Based on height of the peak, we are going to quantify the sample, and the next the area of the peak. Based on the area of the peak, we are going to quantify the sample. The next qualitative analysis. Qualitative analysis means mainly we are going to identify the compound. Identification is based upon the retention time. Every compound has the different retention time. Depending upon the retention time, we are going to identify the sample. Then next, this is a separation of carbohydrates. Carbohydrates having the so many isomers. These are the retention time of different isomers. It means maltose, triose, raffinose, cellulose, like that will be the glucose, sucrose, fructose. These are the different. It means a different isomer having the different retention time. Based on the retention time, we are going to identify the carbohydrates. These are the reference for this PPT. It means the Hplc more mainly the Skoog and Gurdeep Chatwal. Another books also there for the reference. The next, thank you.